Hey geometry team, Mrs. Cerna here. We are going to be going over the review to prepare you for the Unit 7 test. The answer key is already available, but this is just going to be a walkthrough to explain things as we go. So, starting at the very top, number 1, all rhombuses are squares. Is that true or false? This is going to be false. And the reason why is that rhombuses, only the rhombuses that have right angles are squares. But you can have rhombuses that don't have right angles and are not squares. Okay. Number 2 asks, no rectangles are rhombuses. This is false. A rectangle with 4 congruent sides is a rhombus. And we would typically call that a square. Okay? But some rectangles that have 4 congruent sides are rhombuses. Number 3, a parallelogram with a right angle must be a square. That would be another false, because a parallelogram with a right angle is actually typically called a rectangle. And not every single rectangle has 4 congruent sides and is called a square. Some are just plain old rectangles. Number 4, the diagonals of a parallelogram bisect each other. If that is true, then the parallelogram has 4 congruent sides. That is false. This is true for any parallelogram. Every parallelogram has diagonals that bisect each other. And so it doesn't have to have 4 congruent sides. It can be any parallelogram. Parallelogram. And 5, if a parallelogram has 4 congruent sides, it must have 4 congruent angles. That is false. Rhombuses have 4 congruent sides, but they don't have 4 congruent angles. The only one that has 4 congruent sides and 4 congruent angles would be a square. And so not every parallelogram has both. Only the squares do. Moving on. Here we're going to fill in blanks. If the diagonals of a parallelogram are congruent, then the parallelogram must be a what? Which thing has those properties? The diagonals are congruent when the sides are perpendicular, and that's going to be in a rectangle. Okay. If the diagonals are perpendicular, then it must be, well, it's going to be opposite this. And so if the diagonals of a parallelogram are perpendicular, then it must be a rhombus. And so a thing you can remember is that if the sides are perpendicular, then the diagonals are congruent. And if the sides are congruent, then the diagonals are perpendicular. Okay, so that's your rule. They're going to be opposite each other. So if the sides are perpendicular, your rectangle, then the diagonals are congruent. If the sides are congruent, which is your rhombus, then the diagonals will be perpendicular to each other. Okay. Number 8, if the diagonals of a parallelogram bisect the angles, then the parallelogram must be a rhombus. In order for the angles to be bisected up here and down here, you would need the sides on either side to be congruent in order to make these angles be congruent. And that only happens in a rhombus in your parallelograms. It also happens in a kite, but we're focusing on parallelograms here. Number 9, if the diagonals of a parallelogram are perpendicular and congruent, well, if the diagonals are perpendicular, we have a rhombus. If the diagonals are congruent, we have a rectangle. And so if it is both, then it needs to be both a rectangle and a rhombus, and that is going to be a square. And then lastly, if a parallelogram has 4 congruent sides, it must be a rhombus. That is your definition of a rhombus. Yay, page 2. So number 11, we are told that WXYZ, so WXYZ is a rectangle. Automatically, since I know it's a rectangle, I know that all four corners are right angles. Now let's fill in what I'm told. If WY is 17, so if this diagonal was 17, how big would the other diagonal be? So if this one is 17, the other one, it's a rectangle. In my rectangle, the diagonals are congruent, so this one must also be 17. Number 12, if WY, so if this length right here, this diagonal is 31, then how big is ZT? Well, ZT is only half the other diagonal. Now my diagonals are congruent. So if WY is 31, then ZX is 31. So this whole diagonal is 31. And then ZT must be half of it because the diagonals bisect each other. And so this is going to be 15 and a half, or 15.5. Number 13. If the measure of angle TWZ, that's this angle right here, if this is 70 degrees, then how big is WTZ? WTZ is this angle right here. Well, remember that since my diagonals are congruent and bisected, this piece and this piece will be congruent. That's going to make an isosceles triangle here. So this angle has to be also 70. And then, since the three angles together have to add up to 180, this angle in the middle must be 40 degrees. TXW, that's this one right here. TXW, we're going to have to use our other property. So if this angle is right, and this angle right here is 70, then this angle right here is 20. And again, since my diagonals are bisecting each other and congruent, I know that this one and this one are congruent, giving me another isosceles triangle, which means that these two base angles are congruent, and angle TXW must also be 20 degrees. So I'll have 40 for my first answer and 20 for the second. Number 14. Now I'm going to switch colors because I'm on a different problem. If the length of XY is 20 and XT, so this piece of the diagonal is 26, then it wants to know how big is XW. Okay? And so in order to figure this out, I'm going to use my Pythagorean theorem here and some other properties. So I know that this is going to create a right triangle. And I know that this side is 20. Well, the big diagonal here I know will be congruent to the other diagonal. And so this part's 26 and this part's 26. So the whole diagonal here is going to be 52. So now I can use my Pythagorean theorem to find this missing side right here. So I can go that a squared plus b squared equals c squared. And so one of my sides, one of my legs will be 20 squared plus, I don't know how long xw is, and so that'll be my b squared. And my diagonal will be my c, which is 52 squared. And you would get a calculator out here and find out that this is 400. And 52 squared is 2704, which is nice and big. And so you would subtract 400 from both sides. And b squared would be 2,304. And then to solve for b, I would need to square root both sides. The square and the square root cancel. And b is going to come out to be 48 when you plug that into your calculator. So the length of this side is 48. Moving on to GOAT. We've got our greatest of all time rhombus right here. So G-O-A-T. So we've got a rhombus, so automatically I know that all four sides are going to be congruent. I'm going to mark that before I begin so I don't forget it anywhere in here. Then it tells me that the measure of angle OG, that's this whole angle over here in the corner, is 120 degrees. And it tells me that AG, so the length of my long diagonal here, is going to be 24. Using that information, let's figure out the measure of angle TGA. TGA is going to be this angle right here. Well, I know that if this angle is 120, I know that this big angle over here is 120. And I know that in a quadrilateral, all the angles have to add up to 360. So I've got 120 plus 120 plus my other two mystery angles over here and here that are the same have to add up to 360. And so when I work that out, X is going to come out to be 30 degrees. So I know my angle here, is going to come out to be 60 degrees. So this angle is 60 and this angle is 60, which means my little TGA right here, this little half piece, is going to get bisected from there, and it's only going to be 30. Moving on, angle GXO. That's this angle right here in the middle. Well, since I know it's a rhombus, I know that my diagonals will be perpendicular, so this should be a right angle. And so it is 90 degrees. The measure of angle GTO now is right here, this angle. Well, I know that the diagonals bisect, and so this big angle is 120, so angle GTO should be half of that, and it will be 60 degrees. These other ones you have not been asked to do. You can use your 30, 60, 90 properties to find these lengths if you're interested. But we're going to move on to problems 21 and 22. I have told you you do not need to do problem 23. So here I have ELFS is another rhombus. So again, I have 4 congruent sides. And I tell you that ES, so this side right here, is 25, which means that EL is another side. It will also be 25 because rhombuses have 4 congruent sides. Number 22, if the measure of angle LEF, so this angle right here, is 3y plus 9, and the measure of angle ELS, that's the whole thing, is equal to 2y minus 9. Okay, I need to figure out how much everything is. So, sorry, ELS. Okay, well, I know that in a rhombus, I'm going to be bisecting this angle. And so 2 of those 3y plus 9s is going to equal the 2y minus 9. I did that wrong. I apologize. It took me a minute to look at what I was doing. I marked it wrong. This is not the 2y minus 9. ELS is this angle right here. That is the 2y minus 9. Everybody was probably screaming at the computer screen that Mrs. Cerna was messing stuff up. And you're right, I was messing stuff up. So let's cover that up and let's try again. Okay, so this angle is 2y minus 9. This angle is 3y plus 9. And I know that my diagonals intersect at 90 degrees. So I know that this is a 90 degree. So these 3 angles all together should add up to 180 degrees. And so 3y plus 9 plus my 2y minus 9 plus my 90 should equal 180 degrees. And so then I can do my magic 2y. 3y plus 2y is 5y. My 9 and my negative 9 will cancel out, and my plus 90 equals 180. So 5y should equal 90, and y should equal 18. All right, moving on. Problem number 24. COAL is a square. So COAL is a square. So here we're being told that LC is 13. And since it's a square, I know that all four sides are congruent. So when it asks for LA, I know it should also be 13. And then to find AC, I'm going to have to use the fact that a square has right angles. And now I have a right triangle I can use to find the length of AC. I can either use my Pythagorean theorem or I can use my special rights. Knowing that these are all 90 and that the angles are bisected, I know that they'll both be 45. So I could use my special rights and know that this is 13 square root of 2 right off of the bat. Or I could use my Pythagorean theorem and use a squared plus b squared equals c squared. If I do that one, then I'll know that 13 squared plus 13 squared is c squared. So I'll have 169 plus 169 equals c squared. And so 338 is c squared. You square root it, and c comes out to be something like 18.38. And so either way you can get the answer. You can use your special rights or you can use Pythagorean. Either way works. For number 25, now we're going to switch gears. Now we're going to say, well, what if instead of these numbers, what if I said that CA here was equal to 17? Then how big would LC be? Well, again, I can either go backwards from my Pythagorean theorem and end up with 17 over the square root of 2, which is 17 root 2 over 2. Or I could use Pythagorean and say, well, I don't know how long this side would be when I have a diagonal of 17, but I could do x squared plus x squared equals 17 squared. Okay. And working this out, I would have 2x squared equals, this is one I didn't actually work out ahead of time. So 17 squared comes out to be 289. And so x squared is 144.5. And when I square root that, I come out to be 12.02 for my mystery side. So I have a couple different ways to find the length of the side of the square. Once I know LC and LA, LS is going to be half that diagonal I had. So if my whole diagonal is 17, this whole diagonal will be 17, and half of that is going to be, let's see, LS. Yeah, I'm right. So the whole thing was 17, so half of that is going to be 8.5. And my last one on this shape, if I knew that the measure of angle, I want to know the measure of angle ACO. ACO. Well, I know that my angles in a square are bisected, and since the corners are 90, half of that will be 45 degrees. And the measure of angle CLA, that's just one of the corners of my square. It's 90 degrees. Number 27, I've got rectangle math, M-A-T-H. And so I know that I've got right angles in my corners and all the properties of rectangles. I'm told that ST, so this half of my diagonal from here to here, is 20. And the measure of angle AST, right here, is 60 degrees. Knowing that, AT now, this diagonal, should be the same as this one in a rectangle because my diagonals are congruent and they're both bisected. So if ST is 20, then AT should also be 20. The measure of MA here, if I know that this length is 20, I know that this length is 20 right here. And I know that this angle is 60, so I know that this whole angle has to be 120 because they're a linear pair. Then I can use this. I can draw a line right to the middle here, and it's going to bisect this angle, so this will be 60. And so now I can use my 30, 60, 90 setup to figure out how long all my lengths are. So if this is my hypotenuse at 20, then the short side, the 30-degree side, will be half that. And this, so that'll be 10. And then this piece right here will be my short side. It's much more I'm going to set it up on here. I have a 30, 60, 90. I think I did something wrong right here, so I'm going to erase that. See, even the teacher needs to show your work. So I have x root 3, and 2x. And so I have my hypotenuse here is 20. And so my short side should be 10. And so this side should be 10 root 3. So I do have it right. It should be 10 root 3. I have it wrong on my answer key online. Oops, I should fix that. Unless I've done something wrong here. I don't know. I have to look it over. But I'm not wrong. I did it right. So number 29, the measure of angle ATS. So ATS. Well, again, I know that I have an isosceles triangle here because these two diagonals are congruent and bisected. And I knew that this angle was 60, which leaves 120 to be shared evenly among my base angles. And sharing 120 evenly makes both of them also 60 degrees. And then lastly, the measure of angle SMA right here. I knew that this angle right here was 120. And so when I subtract that, I know that this one's 30 and this one's 30. Moving forward. Now we're going to focus on a kite. So the lengths of the sides of the kite. Now in a kite, I know that two of the sides are congruent adjacent and the other two sides congruent or adjacent. And the long diagonal is the one that bisects it, and the short diagonal is the one that gives me my isosceles triangles here. So I know that this is 3 and this is 3, and my diagonals are perpendicular, so I can use my Pythagorean theorem to find WX and XY, which will be the same. So I'll use 3 squared plus 3 squared equals c squared, right there. So I'll have 9 plus 9, so 18 equals c squared. And when I square root, my missing side ends up being 3 square roots of 2, which comes out to be 4.24. And WX and XY will be the same. Then for YZ and ZW, I already know they're going to be the same as well. And I have a side that's 3 and a leg that's 5. So I'll have 3 squared plus 5 squared equals this mystery side here. So YZ. So this one's my C now. And so I'll have 9 plus 25 equals C squared. Then I'll square root both sides. And C is going to equal whatever the square root of 34 is, which is 5.83. And then number 32, for the lengths of the side of a kite again. So this one shows me an opportunity to find a y using my angles. All I want is the side lengths. So I actually don't need those at all. I just need to focus on finding my side lengths. So for x here, I'm going to use this right triangle knowing that my diagonals are perpendicular. So I'm going to use 6 squared plus 8 squared equals that x squared. So that'll give me 36 plus 64, which will be 100 for x squared. So when I square root it, my mystery side right here turns out to be 10. And then since it said side lengths, I'm going to go ahead and find this side length as well. And so for this one, I'm going to use my 8 and my 10 to find my C here. And so I'm going to have 8 squared plus 10 squared will equal my C squared. 64 plus 100 is C squared. And so when I square root both sides, C comes out to be 12.81. So these two were 10 and these two were 12.81. Lastly, moving on to our polygons. What are the formulas to find the sum of the interior and exterior angles of a polygon? So to find the interior angle measures of a polygon, remember you're going to take the number of sides and subtract 2 to get how many triangles you have inside your shape. And then I will times that by 180 to get the number of degrees total for my interior angles. The sum of the exterior angles is always going to be 360 degrees. Okay. Using those things now, I'm going to come down here and say, find the sum of the measures of the interior angles of a 15-gon. And so I'm going to say my number of sides is 15, and I'm going to subtract 2, and then times by 180. And that's going to give me 2,340 degrees for the sum of the angles on the interior of my 15-gon. Now, for number 16, it asks just one interior angle. Well, to do that, I'm going to need to take the sum, the total number I get from a 16-gon. So I'm going to do my formula from up here. I'll say I have 16 sides. I'll subtract 2 to find my number of triangles. I'll times it by 180 to get the total of the angles inside my 16-gon. And then I'm going to divide that by 16 to get just one of the angles. And when I work all this stuff out in my calculator, I get 157.5. Number 35, one exterior angle of a 16-gon. The exterior angles altogether always add up to 360, no matter how many sides you have. So I'm going to take that 360 degrees and share it evenly among all 16 sides. And that comes out to be 22.5 degrees. Number 36. Now we're going to go backwards. I'm going to tell you I have a polygon that one interior angle is 160 degrees and find the number of sides. So I'm going to go backwards now. If I was trying to find an interior angle, I would take my number of sides and subtract 2. I would times it by 180, and then I would divide by the number of sides. And that would give me 160 degrees. Well, I need to work backwards now to find out how much n is. So to do this, to start off, I'm going to say I have an n on the bottom of this fraction. So I'm going to multiply this side by n and this side by n. Those two things will cancel out, and I'm going to be left with n minus 2 times 180 equals 160n. Now let's go ahead and distribute out. 180n minus 360 equals 160n. At this point, once I knew what formula to use, it's just using my algebra to find my n. I will subtract 160n from both sides so that this will cancel out, and I'll have all my n's over here. That's going to give me 20n minus 360 equals 0. Then I'm going to add 360 to both sides, and I know I'm going over the other problem. Calm down. And 20n will equal 360. And then when I divide both sides by 20, n turns out to be 18. So the number of sides turned out to be 18. Now I'm going to do the same thing for 37. I say the measure of one exterior angle is 24. So I knew that the total number of degrees of exterior angles is 360. And if I divided it by my number of sides, it gave me one of them being 24. And now I want to know what this number of sides is. So I'm going to times both sides by n to get that n out of the denominator. And I'll have 360 degrees equals 24n. Now I can divide both sides by 24, and n comes out to be 15 sides. So I have a 15 gon. All right, team, good work. Thank you very much. Study hard, ask questions, and get on Zoom, and be ready for the test.